Hello everyone, this is Mr. H again, and welcome back to my YouTube channel. In this video, you will learn about trigonometric ratios, coterminal angles, and conversion from degrees to radians and vice versa. Alright, so let's take a look at the first part. Alright, so for question 1, we were given a point with coordinates -1/2 and square root of 3/2. And we need to identify these 7 questions here. Alright, but before we answer these questions, let's recall some concepts that we... Alright, so let me draw a unit circle here. Alright, so we have the Cartesian plane. And if you can recall, so for quadrant 1, so both x and y coordinates have positive signs. For quadrant 2, x is negative and y is positive. For quadrant 3, both x and y coordinates are negative. And for quadrant 4, the x coordinate is positive and y is negative. Alright, so let me draw the circle. Alright, sorry about the drawing. So the circle is not drawn perfectly, but it's okay. Alright, so let's start by drawing the radius. We're going to be drawing a right triangle here. And then if you can recall the right triangle, the SOHCAHTOA. So I recommend that you watch the previously uploaded video about trigonometric ratios with right triangles. So if this is our angle, for unit circle, the radius is 1. And you have here cosine theta, and this is sine theta. If this is our point A, so point A will have coordinates of cosine theta, comma sine theta. So basically, we're looking at cosine theta as the x coordinate, and the sine theta is the y coordinate of the point. So let me write a little side note here on top. So cosine theta is equal to x divided by radius. And the reciprocal of cosine theta is secant theta. So which is r divided by x. Okay, so again, unit circle, the radius is 1. Sine theta is equal to y divided by r, and the reciprocal of sine theta is cosecant theta, which is going to be r divided by y. Tangent theta is y divided by x. And reciprocal is cotangent theta, which is x divided by y. So you can refer to these notes up here in answering the questions below. So in which quadrant this point A is located? You can actually tell by looking at the signs, right? So since the x coordinate here is negative and the y coordinate is positive, therefore point A is in quadrant 2. And for sine theta, so sine theta is the y. Just take this value. So square root of 3 divided by 2. And for the cosine theta, we just take the x coordinate, which is -1/2. And tangent theta, so from up here, tangent theta is y divided by x. So we take square root of 3 over 2 divided by -1/2. So if you're dividing fractions, definitely for the divisor, you need to get the reciprocal of this and change to multiplication. So the reciprocal of -1/2 is -2, and we need to change to multiplication. So square root of 3 over 2 times -2 is equal to is negative square root of 3. And for the next question, cosecant theta. It's the reciprocal of sine theta. We just switch the position of the numerator and denominator. So this is going to be 2 over square root of 3. So please take note that since the denominator here is a radical, we need to rationalize the denominator by multiplying the fraction by square root of 3 divided by square root of 3. So 2 times square root of 3 is 2 square root of 3 divided by square root of 3 times square root of 3 is square root of 9, which is 3. So that is the answer. All right, for secant theta, so we need to get the reciprocal of cosine theta. So cosine theta is negative 1/2. The reciprocal will be negative 2. All right, for the last one, cotangent theta, we need to get the reciprocal of tangent theta. So tangent theta is negative square root of 3. So the reciprocal will be 1 over negative square root of 3. So we need to rationalize the denominator by multiplying the fraction by square root of 3 divided by square root of 3. You can put the negative up, it's okay. So proceed with the multiplication. So negative 1 times square root of 3 is negative square root of 3 over square root of 3 times square root of 3 is square root of 9, and square root of 9 is 3. So that's the final answer. All right, so if you think that this question is interesting, so please like the video now and hit the subscribe button so that you won't miss any of my upcoming videos. All right, so let's head on to the second question. Question number 2. For each given angle measurement, state one positive and one negative coterminal angles. So first of all, what are coterminal angles? So coterminal angles are angles that are different in measure, but then they land on the same position on the coordinate plane. So let me draw a figure down here on the right. Okay, say for example, this is the Cartesian plane. Okay, so this is 0 degree or 360 degrees. This is 90. This is 180 degrees. And this is 270 degrees. All right. Say for example, my first angle, given angle is here. Say for example, that is 60 degrees. Right. So to find a coterminal angle of 60 degrees, so basically we'll be counting, okay, so this is 90, 180, 270, 360, plus 60, so that is 420. So that means that 60 degrees and 420 degrees are coterminal angles, okay? And also by observation, you see they land on the same position, so that means that they share the same terminal side. We call this the terminal side. All right, so how do we find one positive and one negative coterminal angles? So if you want to find one positive coterminal angle, you just need to take the given angle plus 360 degrees. On the other hand, if you want to find one negative coterminal angle, you take the given angle, then subtract 360 from it. Let's answer the question. So to find one positive, we take 150 degrees plus 360 degrees will be equal to 510 degrees. Right? And for negative, we take 150, subtract 360 degrees, and it's going to be negative 210 degrees. So maybe you're questioning why we have negative angle here. So the negative sign there tells us the direction. All right, if you can recall, if the given angle is positive, then you're going this way, counterclockwise direction. On the other hand, if the angle is negative, then you'll be going this way, will be clockwise direction. Now, you can pause the video and find one positive and one negative coterminal angles for negative 55 degrees. All right, so let's check your work. So for positive, we take negative 55 degrees plus 360 degrees equals 305 degrees. And for negative, we take negative 55 degrees minus 360 degrees will be equal to negative 415 degrees. Okay, so how about questions 2C and 2D? So if you notice, the given angle is in radian. Definitely, we'll be doing the same process though, but you need to remember that the given angle is in radian. So basically, we need to add the same measure, which is 360 degrees, but it should be in radian. So if you can recall, pi is equal to 180 degrees. So that means 360 degrees will be 2 pi. All right, so to get the positive coterminal angle, we take 5 pi over 2 plus 2 pi. So for 2 pi, we can multiply this by 2 over 2 so that it becomes similar fraction. So 5 pi over 2 plus 2 times 2 pi is 4 pi over, this is actually 2 pi over 1. So 2 times 1 is 2. Now it's easier to get the sum. So 5 pi over 2 plus 4 pi divided by 2 is 9 pi over 2. And to get the negative coterminal angle, so we have to subtract 4 pi over 2. 5 pi over 2 minus 4 pi over 2. 5 pi minus 4 pi is pi over 2. But the instruction told us to find one negative coterminal angle, but pi over 2 is not negative. So that means if that happens, the first time you subtract 360 degrees or 2 pi and it's still positive, then you need to subtract another 2 pi. So it's going to become pi over 2 minus another 2 pi. So minus 4 pi over 2. 2 is negative 3 pi over 2. And that is the answer that we're looking for. Feel free to pause the video and find one positive and one negative coterminal angles for 7 pi divided by 3. All right, let's take a look at your answers. So to get the positive coterminal angle, so we take 7 pi divided by 3 plus 2 pi. And so we changed 2 pi in order for them to be similar fractions. So 2 pi will be multiplied by 3 over 3, so that will be 6 pi over 3. And now it's easier to add, so 7 pi over 3 plus 6 pi over 3 is 13 pi over 3. And for the negative, so we take 7 pi over 3 minus 6 pi over 3. And as you can see, it's going to be pi over 3, which is not negative yet, right? So that means we need to do one more subtraction. So pi over 3 minus 6 pi over 3 will be equal to negative 5 pi over 3. Right? So let me highlight all the answers here. Alright, so if you think that this question is interesting, leave a comment down below. If you haven't liked the video yet, so click the like button and subscribe button. Alright, so let's take a look at the last part. Alright, so how do we convert degree measure to radians? Alright, so let me write down a little note here. So if you want to convert from degrees to radians, we need to take the given angle times pi over 180 degrees. And for the opposite, so if you're given the radians and you need to convert to degrees, you need to take the angle, the given angle in radians, times the opposite. So 180 degrees divided by pi. So 3a we do is we need to take the given angle, which is 170 degrees, and we multiply by pi over 180 degrees. And then we simply cancel out degrees and 0. And we'll have 17 times pi is 17 pi over 18. And that is the answer. And for the last one, you can pause the video and answer the question first. Alright, let's check if your answer is correct. Alright, so to convert from radians to degrees, so we take the given angle in radians. So we were given 3 pi divided by 4, and we multiply by 180 degrees divided by pi. And so we cancel out pi. And then this will become 1, and this will become 45. And we'll have 3 times 45 is 135 degrees. So 135 divided by 1 is 135. So the answer is 135 degrees. Alright, so that's all for this video. If you like this video, please subscribe to my YouTube channel. And thank you very much for watching. And I'll see you in the next one.